Welcome here at Hannover Messe, the marketplace for innovation. Virtual reality in engineering is becoming more and more important, and we are standing here at the Fraunhofer booth of the Institute for Digital Media Technologies with Mr. Jakob Bergner, and they are trying to make 3D models audible. Mr. Bergner, how are you doing that?
Yeah, this is a very interesting question. So what we have on the state of the art is we have some sort of three-dimensional model of a product. So for example, we have a car and we want to try to visualize it. So if you talk about virtual reality, most people mean actually visualization, but it's quite more. So we have a visual model, and maybe we have also a behavioral model. So if we click on door, something is moving. So there is some sort of behavior. But what is still missing is the sound. So what does it actually sound like if I build this model into reality? And that's what we're trying to do. Now you can imagine that a car like this is a very complex sound source. So we have an engine, we have exhaust pipes. If the car is rolling, we have the tire to road noises, and we have maybe wind noises. So different sound sources on one three-dimensional model. And now we can try to oralize it. So if I click on directivity, we have different sound impressions. So if I rotate to the front, I hear more influences of the motor, of the engine. If I rotate to the rear, we have more influences of the exhaust pipes. Now we have here a very unrealistic environment, so it's empty, there's nothing around this. And usually when we think about real reality, we always have some sort of environment, and this is acoustical, very important. So we can switch on the room acoustics. Now we have the car inside of a garage, so this is a little bit more realistic. And we have different walls, different positions of the walls, and different materials. So we can see concrete, we can see some wood, we can see some metal elements. And each of these materials have a specific acoustical characteristic. So there are different reflections. And we can oralize this, the car as a complex sound source within a natural environment.
Okay, and from a technical point of view, how do you realize that?
Usually when we see a CAD model like this, it's built of components or objects. So we have a car which is built of 4 tires and an engine and 4 doors and so on. And we try to represent this object-based approach also in the audio way. So if we have a look into our audio rendering user interface. Now the car is represented as 12 audio objects. And these audio objects are in general movable in this three-dimensional space. So each movement in the visualization is transferred as metadata to our audio rendering, and the audio objects are moving as well. So if I rotate my car, the audio representation, so the 12 sources are moving as well, are rotating as well. If I move within the scene, also the audio representation is moving. I can turn around. Like this. And now the car is in the back. So there are 2 separate isolated softwares, and they are communicating via an interface which contains metadata like positioning and environment.
Okay, and we are talking about the car right now in the model. Is this the only application for your project?
Luckily, it's not. So the car is it's a very useful example. But in general, this approach can be used for any kind of objects. So, for instance, if you want to oralize a washing machine or an electric driller or something like this, you can use this kind of project. Or you can say, I have a machine hall and I want to position different machines to simulate the acoustic behavior and the noise emission. You can just replace this car by any kind of machine, position it in the space, and see how the noise pollution and the general acoustic behavior will change.
Okay, that's enough for the theory. Let's hear it. Now we know how it sounds. As you can see, virtual acoustic product development useful in any kind of engineering. If you want to know more, visit the homepage of the Fraunhofer IDMT Institute for Digital Media Technology. Once again, thank you, Mr. Bergner.
You're welcome.
And have a nice fair.
You too, thank you.